Hello, mathematicians. In this video, I would like to go over proving the law of cosines. Before we get into the video, let's actually go over what the law of cosines is. So, um, in this triangle case, I'm going to name this angle A, and this is going to be B, and then these are just going to be lowercase, just so that we don't get them confused. Essentially, what the law of sine states is that the value of side length A is going to be equal to the square root of B squared plus C squared minus 2 CB times the cosine of A. So that looks like a lot of random stuff that just came out of nowhere. So let's actually figure out where this comes from. Now, it might be helpful before going into this video to look at the law of sines, just because I feel like it's a good build up to this proof, because this one's a bit more complicated, but it's okay, that's not mandatory. And we'll go through it. So the first thing I'm going to do is I'm going to split this triangle into two right triangles like that. So now, because we have these two right triangles, we can start doing trig magic. So if we're going to do trig magic, we're going to want to treat this big triangle as two different smaller ones. So let's define what this side length is and then what this side length is. So I'm just going to pick an arbitrary variable name. I'm going to say that this length, let me draw it out like this so it's a little bit clearer what I'm talking about. This side length is going to be y. I'm just going to say that's y. Now, what do you think this side length will end up being if this is y? Well, this is going to end up being c minus y. Because if this is y, then whatever's left is going to be whatever c minus y is. So now that we actually have these two side lengths defined, let's go over the actual proof. So I'm going to say that this side length over here, the shared side, is going to be x, like this. And whenever you're proving something like this, a great way is to think about how you can take like a side length like this from both sides of the triangle. So like in the law of sines proof, like we took the sine of this angle, and then we ended up with an x here, and then this angle, and then we had another x here. So we're going to do something kind of similar, but it's going to be a little bit different. Instead of using sines, we're actually going to use Pythagorean theorem. So let's do this triangle first. We know that based on Pythagorean theorem, b squared, the hypotenuse squared, is going to be equal to both of the legs squared, so this will be x squared, and then this is going to be this y value because we defined that this side length is going to be y, so plus y squared. Okay, so now we have that one, and now let's do this side next. So the hypotenuse is going to be a, so this is going to be a squared is equal to this value, which is a little bit more ugly because it's a c minus y, so we're going to have to do c minus y squared, and then plus x squared. So already we have two x squares here. So we can use substitution. We're not going to use substitution, but that'll be a good thing to keep in mind as we go through with this. Now, the next step is I want to turn this into a quadratic. So I'm going to do that real quickly. I'm going to rewrite this as a squared is equal to, you can use the identity that essentially states that, I'm just going to write it down here real quickly, a squared minus b squared, oh, sorry, this is going to be a minus b, and then all of this is squared, is going to be equal to a squared minus 2ab plus b squared. So I'm noticing, okay, a in this case is going to be c, and b in this case is going to be y. So I'm just going to rewrite this real quickly as c squared minus 2cy plus y squared plus x squared, x squared. Okay, there we go. So now, using this Pythagorean theorem, I'm noticing that we have a y squared here, and I kind of want to get rid of the y squared, so we do have a y squared in here. So let's put this equation in terms of y squared. So I'm just going to subtract x squared on both sides. So we have b squared minus x squared is equal to y squared. So now I'm going to put this through substitution. So I'm just going to move this equation over to this side so we have more room. A squared is equal to c squared minus 2cy plus y squared, but y squared is essentially this, right? So I'm going to do plus b squared minus x squared. Okay, and then I'm going to add the x squared at the end. I'm going to go back to this part of the equation. So right off the bat, I'm noticing we have a negative x squared and an x squared. So I can cancel those out. Those cancel out by adding like terms. We have a squared is equal to c squared. And then I'm just going to move this b squared over here. So it's plus b squared minus 2cy. And that's essentially what you have so far. Now, I kind of want to get rid of this y. So I'm going to look around at this triangle over here and see if I can put y in terms of something else. Now, just as a hint, this is law of cosines. So we're going to use the law of cosines. No, we're going to use a cosine here. So I'm going to take the cosine of A. And let's just write what that would end up being. So cosine of A, that's going to be adjacent over hypotenuse. So the adjacent value is y over b, which is the hypotenuse. So look, we now have y in here somewhere. So I'm going to multiply this equation, both sides of this equation, by b. So that'll cancel out this b over here. So we end up with b times the cosine of a is equal to y. So now we're going to do substitution again. Hopefully you're not sick of substitution at this point, but this is a kind of a substitution heavy proof. So essentially now we know a squared is equal to c squared plus b squared minus 2c, and y over here, essentially y is just this. So we know y is just this. So we know that this is going to be times b times the cosine of a. And there you have it. Technically, this is an acceptable form of the law of cosines, but if you want to get a just by itself and not squared, that's where the square root comes from. So I can say a is equal to the square root of c squared plus b squared minus 2cb times the cosine of a, and there we have it. So when it comes to putting this into practice, what you're going to want to look at is whenever you have three values that where like an angle pair isn't really present, because if an angle pair is present, you would use law of sines. But here, you'll notice that this is going to define the side length that is opposite. It's going to use this cosine of the angle opposite that side length there. So anyway, I hope that this was helpful. If you want to hear this by somebody else, there's a video that Sal's made, which is pretty good. And then, of course, there are other videos on the internet. But anyway, thanks for watching, and I hope you have a great rest of your day. Thanks for sticking by.